All right, moving on to part 2 of our review for special rights and mostly out of Chapter 5 for our upcoming test. Let's go ahead and take a look at what we have here. I'm going to start off with a special right triangle. And we are given just information that bare minimums here. And we should recognize pretty darn quick that this is a 45-45. And that we have an isosceles, so base angles are the same. So these are both 45 and 45. So that means we have, and let me draw the template right down here real quick for 45-45. And what we have here is if this is A, this is A, this is A radical 2. So all we're going to do is just simple algebra, or just set things equal to whatever. Well, we know that A is equal to 3 radical 6. Well, this right here is A radical 2, so we just put A times radical 2. So 3 radical 6 times radical 2 is going to give me what x is equal to, what this side is equal to. So that's 3 radical 12. Of course, we simplify our radicals. The biggest perfect square that goes into that is 4, so 4 times 3. And square root of 4 is 2. That comes out and hits that 3, so 3 times 2 is 6. 6 radical 3. And we can always do these in the calculator if we so desired. Again, I urge you to practice your abstract reasoning by doing these by hand. But on a test, points matter. You don't want to take risk of some silly little thing. So all you do is just do 3 radical 6, tab over. Oops, I tabbed the wrong way. I'm using my little thingy here. Times radical 2. Boom. And you get 6 radical 3. All right, next example. And again, the whole premise of this is mostly to recognize what kind of triangle this is. Special right, 45-45. You have your isosceles. So example number 2, we have a 30-60-90 because this right here is 60 degrees right here. So let me draw the little template again that you're going to use. My handwriting, of course, is always terrible. If this is 30, we'll call this A. This is going to be A radical 3. And this is going to be 2A. Okay, this short leg is half the size of your hypotenuse. So we're going to take this 18 right here and set it equal to A radical 3. So we have 18 is equal to A radical 3. And I didn't have instructions on this, so barring instructions, I'm just going to fill out all the sides. So I divide by radical 3, so I have 18 over radical 3 is equal to A. I'm going to, of course, multiply both the top and the bottom by radical 3. So I multiply by radical 3 on both bottom. So I have 18 radical 3 over 3, which is 6 radical 3. If you want to do this on the calculator, that is fine. You just come over here and do 18. And you can even hit the divide button. You don't have to do the fraction button if you don't want to. And shift radical 3, boom. 6 radical 3. All right. So the key to this is recognizing the type of problem. And remember, we can flip things around. The 30 degree could be over here. You just got to be careful. The short leg is opposite your 30. So this is your short leg. This is your long leg. And this is your hypotenuse. I'll just call it the hypo. All right. So short leg is opposite to 30. Long leg is opposite to 60. That is your A radical 3. Take a look at another example. I'm going to change the purple. Green does not agree with me today. Here's a good problem. I like this one. What is the perimeter of an equilateral triangle with an altitude of 12? You got to know some definitions here. So let's come up here and do an equilateral triangle. I'm going to draw it out. I got a little bit of computer aid for that. I need to make that bigger, don't I? So let's make that bigger. So I have an equilateral. Known definition of equilateral means it's also equiangular. So here's my angles. They're all the same. They're 60. All right. And an altitude is going from the vertex all the way down to the base here and forming a right triangle. And now on an equilateral, that makes this angle bisector. So this is a 30. This is 60. And this is my 90. And our altitude is 12. Well, again, going back to here, if this is A radical 3, and this is 2A. So we want to find this side right here. Well, we need to find out what a is equal to, so we're going to do the same thing. We're going to have a is equal to, a radical 3 is equal to 12. So we have 12 over radical 3, and by now you should start recognizing that's just going to be 12 radical 3 over 3, or 4 radical 3. All right? So a is 4 radical 3. This is 8 radical 3. That means this is 8 radical 3, and this whole thing right here is 8 radical 3. Okay? So that's just 24 radical 3. 8 plus 8 plus 8, so you got 24 radical 3. Questions? Yeah, you can't ask questions right now, but you can later. So moving on this one. Again, review this problem. This is a problem you want to do on a scratch piece of paper. You should have put this on pause. Go back to where there's nothing written on here and do this problem right now. Again, you don't learn math by watching. You learn by doing. I like this problem. What is the diagonal of a square with sides of 45? Let's draw a square. Let me get a square here. Where is the square? I need a square. And we're going to do the diagonal. Here's the diagonal. One of the properties of the square is the diagonal bisects. Well, squares have 90 and all the sides are the same. Okay? This side is 45. That means this side is 45. Hey, we got a lot of 45s here. This length is 45. This length is 45. So we can just do simple Pythagorean. 45 squared plus 45 squared is equal to c squared over here. Or we can use our definition from our special right, which is a 45-45. Again, if you don't remember, you should. But here's a 45-45. I got to put the 45 in here. And if this is a, and this is a, this is just simply a radical 2. So 45 radical 2. Done. Not much math involved. I didn't want to do the a squared plus b squared thing. That's why we invented higher order math, to make things easier. What is the diagonal of a rectangle? Now rectangles are different creatures, so we better take a look at this. Let's do a rectangle. And do I have rectangles? I do. Here's a rectangle. I'm going to just draw a fairly basic rectangle. One side is going to be 45. One side is going to be 40. And draw your picture. And this is going to be the unknown side. This is nothing more than 40 squared plus 45 squared is equal to c squared. That's all it is. And yeah, I can do it in 1600. I don't know what 45 squared is. I have to think on that. 40 squared plus 45 squared. And I'm going to take square root of that. 3625. And we get 5 radical 145. All right, that's a radical. Okie dokie, that is it for this, and I think that was our last example, so I will get this uploaded with the first one in a short amount of time. I got Pythagorean inequalities coming up next. Alrighty.